Okay, we're going to create a game now, and the purpose of that is so that I can go through all of these steps and try to put them into context for you. So what I'm really looking at is, where are we? Oh, this slide. I want to go through computational thinking, how I think and how I use the computer to solve the solve the problems. In other words, how I actually code the solution. I'm going to start off with an abstraction. I'm going to take, well, it's not a real world problem, it's a game. But I'm going to try to abstract it so that I'm getting rid of all the details and trying to represent a board in a computer. In particular, this is the important part. I'm going to be decomposing everything I do. I'm going to break it down into really small sub-problems, lines of code which are about 4 or 5 lines long, and that's about it. If I get to 10 lines of code, really I should be rethinking my strategy. And I'm also going to be doing some algorithmic thinking. However, I'm not going to be writing any flowcharts or any pseudocode for this. It's basically going to be done on the computer. If I make a mistake and it doesn't work, that's fine. But we're going to cover algorithmic thinking a lot more when we start looking at searching and sorting. And in fact, in some of those, particularly sorting, when we do something called a merge sort, the programming is well beyond the level of this course. We can only sort of do that work by algorithmic thinking and doing it on paper. Mainly because we need to use dynamic arrays and things like that to actually solve the problem, and that's a little bit too complex for what we need to do. So I'm going to be looking at all of these 4 things and combining them all together to make a game. Now, the game that I'm going to create is a GCSE project, which was several years ago, as I've said before, and it was probably more than 20 hours worth of work, more like 40 or 50. It was hard, but then again, it's GCSE level. So really, at the end of the day, the knowledge that is applied to create this game and make it work is the same knowledge that you require for the exam. So rather than get you to program it, think about it, design it and come up with it, I'm going to do it so that you can see how we go through these processes. And the game was a kind of bandits. Let me go through here. I've done a PowerPoint slide. Okay, so this was the game, Bandits. So the point of it is that a player moves around a square grid. That's important. And already abstracting the information here, a square grid, we're going to be using 2-dimensional arrays, which we saw in the last series of videos, in which a number of bandits and a number of treasure chests have been hidden. And I'll explain how we do that later. If the player lands on a treasure chest, he gets 10 gold coins. If he lands on a bandit, whatever coins he's got are sort of stolen, so reset to 0 basically. And the game ends when all the treasure chests have been found. So let me just move on to the way I see it. So this is what I kind of see. This is my grid, my square, so it's 10 by 10 squares, and randomly placed are bandits with B and treasure chests with T. It's up to you what you call them, but that's what I've chosen to do. So they're randomly placed, and the player starts in the bottom left hand corner and can move can move right, left, up or down, and these will actually be hidden. So what you'll see as a player is this, but when we're testing it to make it work, we want to see the chests and the bandits on the screen. But the actual game will look like that, where we just see the player as they move around, rather like battleships. As they land on something, then they either score or lose their points. We may complete the game. That the completion is not really that important. It's the techniques that are used which are important. And as I've mentioned already, this is my abstraction basically. I'm beginning my abstraction where I've got a grid. Now the problem is in Python you can't draw a grid. So if you start thinking about programming that you're going to draw squares to put the T's and the B's in, you're onto a loser to begin with. You have to think abstractly, and that is sort of the next screen that we're going to look at. So rather than have a grid, what I'm going to do is an empty square. I'm going to put a 0, and then I'm going to put my chests and bandits in there, and my player in the bottom left hand corner. And again, if you're playing the game, what you'll see is just that, just the player and a load of zeros on the screen representing the table to go through. So that is an abstraction. We've taken out some of the detail. In other words, the detail of drawing squares on the screen to make our game work. Now, depending on the language that you're working with, if you're using a graphical language, then maybe you could do the squares. But as we're using Python and we can't draw these on the screen, we have to use zeros to represent the squares. Now, let's nip over to Python to begin with. I just want to finish off this kind of abstraction. What we've got is a grid. It's an array of arrays. It's two-dimensional. It's a table. The first array is this one with 10 zeros. So I could, let's just do 4, otherwise I'll be typing forever. That's sort of my first row in the table. Okay, it's only up to here. Okay, I'm only doing those 4, just to save me typing. Then if I come down, my next row is going to be another array of 4 zeros. Whoops. That's my second row. And if you think about it, I'm using terms already. Oops. So we're abstracting, we're getting rid of the detail, we're pulling out the information that we need, and I'm using the term row. So let's just do a couple more. Let's just do a square, so it's 4 by 4. And then the final one. So that's going to be the 4 rows of 4 columns. So each one of these is going to be in a column. So if I aligned these under one another, we can see that we've got 4 rows and 4 columns. So I can also use the term column. So these are going to turn out to be variable names in my program. Again, abstracting the detail out. Algorithmic thinking. So I'm thinking about the algorithm at the moment. And as I've said, this is going to be an array of arrays. At the moment, there's 4 arrays. Wouldn't work. I need to encompass all of those as an array. So that would be sort of my data type that I am looking for to create my program. But one thing I don't want to do is type these out. I don't want to be typing 10 rows of 10 columns. That's going to take forever, and it's not going to be very easy if I want to change it. So later on I might want to have 15 by 15 grid or a 4 by 4 grid. I want to be able to use variables such as size of my grid. So I'm beginning to pull variable names out that I shall be using in my program. And maybe we want to reference them as we would do like on a graph, using x's and y's, x for the column and y's for the rows. Again, abstraction, algorithms, pulling the information out that we might need. So in the next video, I'm going to start thinking about how to make this game work, what I'm going to need, and if you can, follow along. It is going to get complicated, so maybe after the first section, once I've just decomposed the problem a little, then maybe you just watch and type in. I don't know, up to you, but I'm promising it will get a little bit complicated.